has an area of 0.5 meters squared. The specific gravity of seawater is 1.03. Assuming that acceleration due to gravity G is equal to 10 meters per second squared, and neglecting the atmospheric pressure, water is force exerted by the seawater on the hatch door at depth of 200 meters. Solution: area A is equal to 0.5 meters squared. Specific gravity Sg of the seawater is 1.03. Depth H of hatch door in water is 200 meters. Force F is equal to pressure P times area. Force is equal to PA, but pressure is equal to H density gravity, that is height times density times acceleration due to gravity. Therefore, force F is equal to height times density times acceleration due to gravity times area. Therefore, the force now become equal to 200 times 1.3 times 10 times 0.5, which gives us 1030 Newton, or 1.03 times 10 raised to power 3 Newton. Question 11. A mango fruit dropped from a branch 10 meters above the ground. Calculate the velocity just before it hits the ground. Taking acceleration due to gravity to be 10 meters per second squared. Solution: S, this is the distance, is equal to 10 meters. Acceleration due to gravity G is equal to 10 meters per second squared. And the initial velocity, which is u, goes to 0. Since the body is initially at rest, from the third law of the equation of motion, we have that v squared is equal to u squared plus 2gs. V squared, which is the final velocity, is equal to initial velocity, which is 0, plus 2 times 10, which is the acceleration due to gravity, times 10, which is this distance. Then the v squared will now become 200. V is now equal to square root of 200, which gives us 100 times square root of 2. V is now equal to square root of 100 is 10 times square root of 2 meters per second. Question 12. A train has an initial velocity of 44 meters per second and an acceleration of minus 4 meters per second. Calculate its velocity after 10 seconds. Solution: U is equal to 44 meters per second. A, acceleration, which is equal to minus 4 meters per second squared. T is equal to 10 seconds. V is equal to unknown. From the initial equation of motion, the first equation of motion, we have that V is equal to U plus AT. Therefore, V, that is the final velocity, is equal to 44, that is the initial velocity, plus minus 4 times 10, which is the time, which now gives us 44 minus 40. Therefore, the final velocity is now 4 meters per second. Question 13. A force of 16 Newton is applied to a 4.0 kilogram block that is at rest on a smooth horizontal surface. What is the velocity of the block at t equal to 5 seconds? Solution: force is equal to 16 Newton, mass m is equal to 4 kilogram, u, that is initial velocity u, is equal to 0 since it is at rest. T, which is the time, is equal to 5 seconds. Using the formula, F is equal to mass times acceleration, where A is the acceleration. Therefore, 16, which is the force, is equals to 4a. Therefore, a, making a the subject of the formula, you have 16 over 4, which will now give us our a to be 4 meters per second square. Using the first equation of motion, which is v equals to u plus 18. Therefore, v is now equal to 0 plus 4 times 5, which will give us 20 meters per second. Question 14. If a simple pendulum with a period of 2.0 seconds has its length doubled, what will be its new period? Solution. Period t of pendulum period is directly proportional to the square root of the length, or t is equal to k times square root of length. K, the constant, is equals to t over square root of length, which is equals to 2 over square root of length, or which is now equals to x over square root of 2l. X times square root of l is equals to 2 times square root of 2l. S is now equals to 2 times square root of 2 times square root of l all over square root of l. Square root of l cancel out, leaving us with s equals to 2 times square root of 2, which will give us 2.83 seconds. Question 15. A body of mass 5 kg initially at rest is acted upon by two mutually perpendicular forces, 12 Newton and 5 Newton, as shown in figure 1.53. If the particle moves in the direction OA, calculate the magnitude of the acceleration. Solution. Figure 1.54 example have formed a right angle triangle. According to the law of Pythagoras, the square root of the hypotenuse is equal to the sum of the square root of the other two sides. Therefore, the hypotenuse r squared is equal to 5 squared plus 12 squared. R squared is now equal to square root of 5 squared is 25 plus square root of 12 is 144. R, adding and making r the subject of the formula and crossing the square, we have the square of 169 will give us 13 Newton. From force is equal to mass m times acceleration a. Therefore 13, which is the force, is equal to 5, which is the mass times acceleration. Making a the subject of the formula, we have that the acceleration is now equals to 13 over 5, which gives us 2.5 meters per second squared. Question 16. Velocity time graph, figure 155. The graph in figure 155 above describes the motion of a particle. What is the acceleration of the particle during the motion? Solution. A is equals to, in bracket, final velocity v minus initial velocity u all over t. The slope is now equals to, from the diagram, the slope is equals to v minus u over t, which is equals to a. But we are given that v from the diagram is the final velocity is 10 meters per second, and the initial velocity u is equal to 2 meters per second, and the t time, which is 2 seconds. Therefore, substituting the value a, it will now be equal to 10 minus 2 meters per second all over 2 seconds, which will give us 4 meters per second squared. Question 17. If a car starts from rest and moves with a uniform acceleration of 10 meters per second for 10 seconds, calculate the distance it covers in the last